The job description of a data engineer centers around designing, constructing, and maintaining scalable data architectures that facilitate efficient data collection, storage, and access. These professionals build the backbone of modern data systems, enabling data scientists, analysts, and decision-makers to draw valuable insights from massive datasets. Employed across industries including finance, healthcare, retail, tech, and manufacturing, data engineers play a crucial role in turning raw, unstructured information into organized, actionable formats that organizations can rely on. Data engineers are responsible for developing robust data pipelines that collect data from a variety of sources, web applications, databases, APIs, and external platforms. They clean, transform, and store data into formats suitable for analysis or machine learning. With the explosion of big data, cloud computing, and artificial intelligence, the demand for skilled data engineers has surged, making this a cornerstone role in the data ecosystem. Unlike data scientists who focus on interpreting data, data engineers concentrate on ensuring the infrastructure and processes behind the scenes are optimized, secure, and scalable. Their work often involves collaboration with software developers, IT teams, and business stakeholders to ensure that data architecture aligns with organizational goals. This technical position requires an excellent grasp of programming, database design, system integration, and modern data technologies. Core responsibilities of a data engineer. A data engineer's primary responsibility is the construction of data pipelines, which are automated processes that extract, transform, and load (ETL) data into a central repository. These pipelines must be fault-tolerant, efficient, and capable of handling real-time or batch data depending on the needs of the organization. Building such systems requires proficiency in languages like Python, SQL, Scala, or Java. In addition to pipeline development, data engineers create and manage data warehouses and data lakes, large storage repositories where vast amounts of structured and unstructured data are maintained. They ensure that these environments are optimized for performance, enabling quick access and processing by downstream users. Familiarity with platforms such as Amazon Redshift, Google BigQuery, Snowflake, and Apache Hadoop is often essential. Another significant part of the job is data modeling. Data engineers design schemas and tables that reflect the relationships between different data entities. Proper data modeling ensures consistency, eliminates redundancy, and facilitates more efficient data queries. They may also work with metadata management tools and establish data governance protocols to maintain data quality and compliance. Monitoring and troubleshooting are ongoing duties. Data engineers must regularly inspect the data flow for errors or anomalies, correct performance bottlenecks, and address pipeline failures. They are also responsible for documenting processes and ensuring that their systems are scalable and capable of adapting to evolving business requirements. In modern data stacks, data engineers often leverage workflow orchestration tools like Apache Airflow or Prefect to automate complex ETL jobs and data refreshes. They may also work with streaming data platforms like Apache Kafka or AWS Kinesis when dealing with real-time information. As organizations increasingly move to the cloud, data engineers are expected to have expertise in cloud-native services provided by AWS, Google Cloud Platform, or Microsoft Azure. This includes configuring storage, managing compute resources, and securing data access through Identity and Access Management (IAM) protocols. Essential skills and technical expertise. To excel as a data engineer, one must possess a well-rounded set of technical and problem-solving skills. Chief among them is proficiency in programming. Most data engineers are fluent in Python or Scala for data transformation tasks and use SQL extensively for querying relational databases. A strong command of these languages is fundamental to the role. Knowledge of database technologies is critical. Data engineers should be comfortable working with relational databases, like PostgreSQL, MySQL, Oracle, and NoSQL databases, like MongoDB, Cassandra, or DynamoDB. Understanding the strengths and limitations of each helps them choose the right tools for different types of workloads. Experience with big data frameworks such as Apache Spark, Hadoop, or Flink is often a prerequisite for positions in large-scale data environments. These tools allow data engineers to process massive datasets across distributed systems efficiently. Moreover, familiarity with data lake formats like Parquet, Avro, or ORC is also beneficial. Another key component of the job description is familiarity with version control systems like Git, CD pipelines for deploying infrastructure as code, and containerization tools like Docker or Kubernetes. These tools are essential for managing environments, ensuring reproducibility, and deploying updates with minimal downtime. Communication is an underrated yet vital skill. Data engineers frequently work with business users who may not be technically inclined. The ability to explain complex systems clearly, gather requirements, and translate them into data solutions is crucial. Collaboration across cross-functional teams ensures that data systems are aligned with strategic objectives. Security and data privacy are also critical concerns. Data engineers must implement proper encryption, data masking, and secure access controls, especially when dealing with sensitive or personally identifiable information, Compliance with regulations such as GDPR or HIPAA is often necessary depending on the domain. Work environment and typical challenges. Data engineers generally work in office environments, although remote work has become increasingly common with the growth of cloud infrastructure. Their daily routine involves a mix of coding, system monitoring, collaboration meetings, and documentation. One of the main challenges is dealing with incomplete, inconsistent, or dirty data. Unlike curated datasets, raw data often comes with errors, duplicates, or format issues. Cleaning and transforming such data into usable formats is one of the most time-consuming aspects of the role. Keeping up with evolving technology is another challenge. The data engineering landscape changes rapidly with the introduction of new tools, frameworks, and cloud services. Continuous learning is necessary to stay current and ensure systems remain modern and efficient. Another common issue is system scaling. As organizations grow, their data grows exponentially. Systems that worked for small-scale operations may begin to buckle under increased load. Data engineers must proactively design scalable systems and anticipate performance bottlenecks. Amid these responsibilities and technical considerations, it's worth emphasizing that the job description of a data engineer is more than just coding pipelines. It's about enabling organizations to harness the full value of their data. Data engineers are foundational to building a data-first culture that supports innovation and informed decision-making. Educational background and career path. Most data engineer positions require at least a bachelor's degree in computer science, information systems, software engineering, or a related field. Some employers prefer candidates with a master's degree, particularly for senior roles or positions involving complex architectural responsibilities. Certifications can enhance a candidate's credibility. Credentials from cloud providers such as AWS Certified Data Analytics, Specialty, Google Cloud Professional Data Engineer, or Microsoft Azure Data Engineer Associate demonstrate proficiency in cloud-based data systems. Other relevant certifications include Cloudera Data Platform Generalist or Databricks Lakehouse Fundamentals. New entrants to the field often begin in roles such as junior data engineer, data analyst, or software developer. With experience, they may progress to senior data engineer, data architect, or platform engineer roles. Some move laterally into roles focused on data science, machine learning engineering, or analytics engineering depending on their interests and additional skill development. For professionals seeking a dynamic career at the intersection of technology and strategy, data engineering offers a compelling pathway. It combines deep technical work with high organizational impact and offers strong career growth, especially as data continues to play a central role in business success. Conclusion. The job description of a data engineer illustrates a career that is highly technical, immensely valuable, and constantly evolving. These professionals ensure that data flows smoothly from source to insight, empowering others to make better decisions, build predictive models, or design smarter systems. In an era driven by digital transformation, data engineers are the architects behind the scenes, constructing data highways, setting quality standards, and safeguarding the integrity of information. Their work may not always be visible to the end user, but it is critical to the success of any data-driven initiative. For those passionate about problem-solving, system design, and continuous learning, data engineering offers a rich, rewarding professional journey.